Jianwei join me on this panel. And today we're going to discuss intelligent robots. We have 30 minutes, so the way I would like to structure the panel is for Dr. Adam as well as Dr. Jianwei to introduce themselves in terms of their background as well as their primary focus within a company or primary focus of most recent projects and products. And then we can have more domain discussions in the areas of artificial intelligence. Adam?
Okay, thanks very much. Okay, great. So my name is Adam Pease. I'm the head of R&D for natural language processing at a company called Cloud Minds. We're a fairly early stage stealth startup, but very well funded, fortunately. So we were started by an entrepreneur named Bill Huang, who also founded UT Starcom, so some of you may be familiar with him. He's a true genius about raising money as well as a visionary in the area of robotics. And so my charter has been to build a team to do natural language processing on cloud-connected robots. I have some particular interests in a sort of contrarian approach in artificial intelligence. We might call it what's old is new again. I'll actually talk about that in my keynote, but it appears that I'm going to have to run off to my keynote in the middle of this panel, so I will try to balance between the two approaches as best I can.
That's great. Dr. Jianwei.
I'm Jianwei Zhang. I graduated from Tsinghua University and almost 30 years ago. So I first applied artificial intelligence in robot motion planning 30 years ago, and since then I've been working on robot control, path planning, and robot learning. So since the last 30 years, and I was the general chair of the last IROS conference, the largest intelligent robot conference in Hamburg. So my Hamburg team is concentrating on multi-sensory processing and some robot learning on different levels, from skill level to experience level. And I have also two teams in China, one in Shenzhen, one in Shanghai. So the Shanghai team is concentrating on the modular robot, and the Shenzhen team is working on medical and such medical devices automation. So these two teams in China with experience on mechatronics and intelligent robots. In Hamburg mostly on the software side.
Great. So a very quick introduction of myself, which I forgot to. I'm Tammy Zhu. I'm general manager of Rocket. The company is headquartered in Hangzhou, China. Very well funded, and we've been ranked as top 10 worldwide Series B, largest funding in the AI space most recently. We won 2 CS awards this year and 1 last year, and quite a number of other accolades. And so after the panel, if you have interest in discussing further, we can certainly have more time to discuss that. So, Dr. Adam, I know you are running out of time. In the hallway, Dr. Adam had conversations in terms of comparing expert systems to deep learning and machine learning, which made me realize how not knowledge I am. So I also feel it's important for Dr. Adam to help us set the level playing field. So perhaps, Dr. Adam, you could explain in very highlight summaries of 20 years ago the approach compared to today, and what are some of the pros and cons, and also your personal point of view, how that works.
Yeah, so thank you for that. For any of us who have been in AI for multiple decades, there have certainly been some fantastic transformations that have occurred. Is it my time to leave right now? Okay, well, that was a very short talk, but I'll be back. Thank you very much.
All right, Dr. Adam. All right, so Jianwei, so you have teams in Germany as well as in China, in Shanghai, as well as Shenzhen, as you explained. Can you tell us, in terms of the application that you have in mind, what type of products you envision to be, pushed out to the market this year or next year?
Generally, so if we talk about the non-industrial applications, we have in mind about 8 areas. So from education to service to medical to surveillance, cleaning, and so on and so forth. And so currently the most used service robot is the cleaning. So from the vacuum cleaner, so this is the largest number of service robot in the world. But there will be some other kind of cleaning, so, such as table cleaning, wall cleaning, and also some large area, business area cleaning, use water, use brushes. And I think cleaning will be continuously be an area that can be further explored. So it's without doubt, it will be some other kind of robot will do the cleaning. But also, I believe in the area of education, so there will be a lot of needs from the schools to the professional education to the universities, especially China. Also in America, I think the STEM education is a very good market for robots. And of course, there will be a lot of competitions. There's a very large number of small companies. But there will be also a lot of space for more companies. For example, modular robot, and also combination with other education philosophies, or combination with robot and the new teaching method. And education, I believe, that's also why we developed this modular robot.
So can you articulate in what ways that robots would be playing a role in education, and also perhaps provide some context in terms of common points and also differences in the United States and China? Because I was also born and raised in China, in the Chinese education system, also educated here, so the systems are very different. So I would envision the robots would play different roles to facilitate teaching.
Yes, I think first, robot can be used for teaching programming. And in my time, we learned programming always use terminals, and nowadays there's a lot of progress to learn programming. One colleague in California is doing very good business by only selling his software to learn the programming C language. Over the world, there's a lot of users. But nowadays, I think we can use also robots to let the young people, the children, to learn programming by C, and it's more very much intuitive to see the robot run, and also especially to program the embedded systems. And I think use robot to children to learn programming. And then the second way is to let the children learn to learn teamwork. And because the robot usually cannot be done by one person, and the teamwork, especially for the Chinese children, is very important. And to let the team build robots and then to do competitions. And I'm now invited by him in China to government background. New kind of competitions in the children, so use more robot applications and learn knowledge for robots. And then the third area is to learn innovation, and you can provide some basic components, so to let the children to build new kind of robot, and to realize this kind of open scheme. So without any set robot only do the programming to do every kind of fantasy based robot. And then I think, especially in China, there's a lot of investment in teaching technologies, and especially robot. And in China, the speciality is that you should associate with kind of using robot in education with some benefit for entering better universities. If you can add some special qualifications, add some credit for entering Tsinghua, for example, will be a huge market. And, if not, you need to have good knowledge with environment rules, and why this kind of robots will be useful for competition or usage. So in America, probably it's more free, and if the children like it and love it, market is different.
Right. So in terms of, do you have a question?
Yeah, actually, I have a
Go ahead.
question for you.
Yeah.
So, can you explain a little bit like what the rocket does? And I looked on the website. Roughly, I see it's you are doing like smarter home products.
Right.
And can you explain a little bit more what it does, and also how does it compare to like a Google and Amazon solution?
Sure.
Yeah.
I can certainly explain what Rocket does, but let's because Jianwei has a very good point. Let's finish the education subject, and then let's move on. So, so Jianwei, I have a question in terms of artificial intelligence in education, right? In China, it's at least during the time I was brought up, it was about uniform teaching, right? Everyone sitting in the same classroom, you enter in the exact same exams, and then you're ranked from number one to number bottom. And the best students get to go to the best colleges, and the worst students probably didn't get into any college. So it was very much of a one system, one size fit all type of program. Whereas in the United States, there is emphasis over individuality. So in particular, when it comes to teaching, there's higher awareness and more respect for each individual student being different. And in particular, some have special needs, right? So, so there is the vision of artificial intelligence in education is that robotics can provide customized learning at scale, in particular in schools with restricted funding. So what do you think about this? Is this just a idealistic point of view, or it is truly practical and doable?
I think ideally it's really AI and robotics are wonderful means for children to learn the individual creativity, and then to fully use their fantasies and be able to develop some learning skills. But practically, especially in China, it's still very difficult to write some rules and to comply with the current education system and how to evaluate such performance, and then to let the children, let the teacher so benefit from such extra activities. So beside the school, and so in China, so they have very strong pressure for entering the good universities. Now, for example, Tsinghua is now changing also a lot to try to extend the proportion of students without examination. But so how to evaluate this extra performance is a very good point, and to let the education ministries and also the university department for acquiring children, the students, they accept these rules. It's a very long process, but it's definitely an interesting direction. Probably it's easier for the states and Germany to accept this in the education system first.
Got it. All right. So perhaps for the next subject, we'll talk a little bit about Racket to answer your question, and also I'll welcome Dr. Jian Wei as well as other people in the audience to comment and ask questions about Racket. So Racket is a company that's 2.5 years old. We are a consumer artificial intelligence company, and the first product, I don't know whether, so you probably have done a little bit of research, right? The first product, we call it Racket Alien. We started shipping in China back in April, so almost a year ago. Initially online on Tmall with partnership with Alibaba, and now we're selling in over 100 stores in China. And in the meantime, we're doing development on Racket Pebble, which is a much smaller product. The timeline is going to be spring this year and launching in China initially. So this is the overall summary. And so our long-term mission is to bring robots into consumers' homes, right? But then if today we bring robots, there will be too many moving pieces. It's almost impractical to do every aspect of robotics well. So we decided to focus on one thing at a time. So the initial focus is natural language processing. So we actually have a team of PhDs from the Chinese Central Academy of Sciences, 中科院, and so they're located in Beijing. So they built the entire language framework, ASR, and NLU, and also TPS from ground up. So with our current product, you can converse with Melody, which is the name of our service. You could ask about information, for example, weather, ask music, news, restaurant information, order Uber, and also the product can manage your smart home devices. In China, our product is compatible with LifeSmart, Meidi, Broadlink, Xiaomi, and in the United States, we're compatible with Google Nest, Hue, and also Wink. So, but then in China, we haven't, in the United States, we haven't started selling yet, and this year is a big goal for us, actually. And then your second question was, how do we differentiate from Amazon Echo and Google Homes, right? Our point of view is that we don't want to compete head-to-head with these products. We feel very, very thankful that Amazon Echo has been enormously successful in that it really educates the consumer base. So we don't have to go to the consumer base and say, hey, you really need this product. So instead, we can just focus on differentiation. So a few of the key differentiations. Number one is multi-channel communication. So for example, for Echo, it's only audio, so you talk to the product. The product has the voice, right? But you don't get to see the personality. For our product, beyond just voice, we have DLP projector, front screen, we have touch sensors, we have facial recognition, gesture motion recognition. Also, we have voice print, which sets the automatic security as well as personalization. So when you talk to Melody, for less than 1 second, Melody knows that's your voice, not Dr. Jian Wei's voice. So Melody plays to your song, orders your Uber, goes to your account, right? Tells you about your favorite restaurant. So we view that as a huge differentiator. Whereas Echo, they don't really have the incentives of knowing who that is. As long as you order as much as household supplies, right? That's their e-commerce motivation and agenda. So it's a very, very different point of view in terms of building a business. And also, we focus a lot on UI, UX design, as well as industrial design. We want to make sure our product is not just a consumer electronic, for example, TV or speaker, right? Or wallflower somewhere in the background. We want our product to be your family companion and has a character, right? From the look and feel, from how you interact. On top of that, we build a full stack of technology. So far, we have over 400 patents pending worldwide, and over 100 have been granted. So this is a quick summary. So Dr. Jianwei, do you have criticisms?
No. I have visited the company in Hangzhou. It's very impressed. So many researchers, also students doing practical course there, and it's a very lively development. Really, very good atmosphere. And so you simplify the robot product to a very practical purpose. I think. First, to let the user have some feedback, evaluation, iteration. That's very, very important because you know there's a lot of robots now, mobile robots now in China developed and also have the function of dialogues. So they are very much similar with each other, and no differentiation. And not concentrating on the user experiences. I think it's a very good start as a personal assistant. So my question is, do you think that later there will be the direction also to let the robot has some degree of freedom, first with one, or then two, or then even mobile, or later, but what you would consider role?
Yeah. It's a very good question. Yes, in the long term, the end game, right, is we want real robots that actually move around and works. Actually, Pepper, for example, right, has been a hit this year. At least they got a lot of attention. However, I think there are also a lot of other areas they need to work on. But motion is one of their focuses, right? So we have two labs. One is based in Beijing and one is based in San Carlos. The San Carlos lab, we call it robotics lab. It's a team of PhDs. Most of them came from Berkeley. Their goal is to focus on futuristic. Exactly to your point. So Dr. Adam is back. Welcome back. So let's revisit the question we have covered earlier in terms of drawing some differences and similarities between artificial intelligence 20 years ago, right? Expert system and symbolic reasoning versus now. There's a lot of buzzwords in terms of deep learning, machine learning. So please tell us more.
Yeah, thank you. So I think where I left off was trying to say it's great when people have been in the field for several decades because you get a perspective on the cycle of excitement on different technologies, the cycle of hype, of overpromising, the hangover that happens after that cycle of hype and overpromising, and then sometimes some real work happens after that point. After the overinvestment has happened, after the overpromotion has happened. And that, in my mind, is what has happened in symbolic logic. That is not to take away anything from the tremendous rush that's occurring now and the tremendous scientific advances that are happening in machine learning. But the problem space has changed. The things that we all tried to do in symbolic artificial intelligence and expert systems back in the 80s, that was one really good problem, right? So you've got a question, you have an expert, maybe somebody who's retiring. They have this body of sort of rules of thumb, things that are mostly true most of the time, that need to be chained together to give a conclusion. and you try to pick that person's brain, record that information. That was actually a success. For some reason, there's this view that expert systems were not successful. They were successful. They just didn't solve every problem out there. They were so successful they became part of the background. They stopped being AI. They became conventional computer programming in a way. And then machine learning kind of took over. We had all these exciting applications about it. It just looked like magic, right? You could run a mathematical algorithm, and all of a sudden you didn't have to code anything by hand. You just got answers. If those answers were right, most of the time that was good enough. But the problem space changed. The problem space changed to pattern recognition, face recognition, handwriting recognition, information retrieval, where you're retrieving matches to sentences. Those are fantastic problems that obviously have a huge business impact. But there's more to intelligence than that, right? People do things like deliberation and planning, things that are not handled very well through pattern matching algorithms, where we have multiple steps of inference or deduction or sub-conclusions that have to happen. Think about solving any hard problem that you need to solve in terms of planning a trip. It has many, many steps, and it has many steps that are quite true. Rules that are quite true, things you can't do. So I don't know how much length you want me to go into. There was a great project that I wasn't on at NASA 20 years ago. They were using genetic algorithms, right? So at the time, genetic algorithms were a real hot numerical pattern learning algorithm. And they were trying to design a more fuel-efficient plane, because NASA does a lot of aeronautics research. And so they crunched away for a while, and they came up with this great design. This plane was flying really fast and hardly used any fuel. And then they started to look at the results, and they basically had the plane flying backwards, generating fuel. Right? Brilliant solution, because the problem that the program was given didn't have these real-world constraints. It had no common sense. It had no real-world knowledge. It came up with a great solution in terms of the problem it was given, but it wasn't a good real-world solution. It was stupid, right? Because it didn't have any human intelligence. That's part of what I think is missing right now. Part of what we're going to need to add into our robotic systems. I call these cognitive guardrails. They're things to stop the robot going off the road, right, and doing things that are dumb. Because right now our robots don't have much common sense about the world. They don't understand what is a person, that people can be hurt. They might understand obstacle avoidance. Everything is kind of the same in its domain of discourse and knows to stop and not bump into things. There's a slide I often put up about, if you've got an industrial robot that just does welding, then everything is an object to be welded. If humans goes into that space, then the human's just another object to be welded, right? Because that's its domain of discourse in a mathematical sense. That's all it knows about. That's the stuff that needs to change, and that's where symbolic reasoning can help rescue us from and our robots from bad decisions.
Thanks, Dr. Adam. So, Jianwei, what do you think? Do you think what are some of the shortcomings of the most-term approach compared to 20, 30 years ago? Obviously, when you were a kid.
Yes, I think now the current progress in AI mostly come from the big data, a lot of statistics learning, and make the speech recognition and also the image recognition so practical now. And then the next trend is to ground the symbol with this automatic data. I think that's what we are calling the layered learning, and then to let the intelligent system understand the concept, labels, even complex common sense knowledge is high-level knowledge. And we have several research projects on that, but very preliminary. I think it needs 30 or even 50 years to go to fully understand the whole concept. To ground every single real data, real learning process.
My sense is we can accelerate that, right, if we take advantage of symbolic processing. Because indeed, the advances in the perceptual portion of robot action have been phenomenal. They're all machine learning based. So the things that people were doing with Shaky the robot at SRI 30 years ago, were all driven by symbolic reasoning. They were a failure, because the problem wasn't suited for the solution. But now everybody looks at all of these nails and thinks they have just one big hammer of machine learning. There are other tools in the toolbox we can use than just this one fantastic hammer. And I think if we try grounding perceptual stuff like identification of images, right? So great, we can identify a face or a toaster or a coffee cup. Wouldn't it be nice to have a set of pre-existing information about what it means to be a coffee cup? Coffee cup might have this kind of material. What is it for? It's for drinking. You might know something that way about these objects in the real world without having to learn through massive data all the stuff about knowing that a coffee cup is for drinking because you've seen 5 million images about somebody using a coffee cup for drinking. Or knowing that as a solid object, I might, in a pinch, use it to hammer something down, right? That I may never have seen, but that I know is common sense without ever having experienced it. Because I can reason about that. I know something about what this object is for in the real world. That's what symbolic reasoning can give us. It can be an aid, it can be the cognitive support system for robots that are brilliant in the perceptual world.
Got it. So for the last question, I want to get your point of views on, for the next 5 years compared to the past 5 years, what are some of the significant breakthroughs that you envision that we could potentially have in artificial intelligence? And knowing, obviously, it's going to be a long road, right? Professors and scientists and a lot of us have worked on it 20, 30 years ago till now. But 10 years ago, we were very ironic. We felt like we will never be able to make breakthrough, right? Even though in our imaginations we could. So I would love to hear your point of views or the outlook of artificial intelligence. What's going to happen in the next 5 years?
Well, this is like being given candy, right? It's prognosticate on the future of the science that we all love, right? So I would say there's sort of generally 2 responses you get to this. One, oh, it's never possible, we can't do this all. It's just hopeless. Or, of course we can, and I'm going to do it, and that's what my company is for, and in the next 5 or 10 years we're going to solve all these problems. So in the first AI conference at Dartmouth, right? I mean, Marvin Minsky and Cordell Green and John McCarthy, I think all said something equivalent about, give us 10 years and we'll solve it, right? No problem, right? And people say this every 10 years. That's a great period. I think 5 is too short. Everybody's real comfortable with 10 years out. All the things we don't know how to do, we'll be able to do. So I'm not sure I want to predict that, but I will say that I think the answer is going to be in combining these different tools in our toolbox, and not just doing numeric stuff, but also doing symbolic stuff. Make a solid effort on that. If we educate people also in multiple disciplines, this is a key problem in science, but particularly in AI. People get wedded to one approach, all their background. Like we're teaching physicists how to do computer science. Great, if you're a physicist, what are you going to do? You're going to do math. That's what you know how to do, right? And maybe language isn't kind of your thing. And so if you can just reduce language to a bunch of numbers and run an algorithm over it, you're going to be happy because you're a physicist, right? Maybe we need to start hiring these linguists that have been studying, how to represent 12th century Dutch things, or publications about Beowulf and stuff. Those people actually have some really good knowledge about how language works. If we can bring some of that back in, I think progress will be more rapid.
Got it. Dr. Jianwei, what do you think?
I think that in some areas there will be some good application of AI agents, such like robot advisor. First in financial area, wealth management, for example, and also for industry applications, how to predict the supply chain, and also for some medical applications to consult your medicament, and also for some healthy habit. And I think this robot advisor will be playing a good role for the coming years, and then use robot as a kind of assistant will be also very promising, and that's why artificial intelligence is viewed as one technology that can be applied everywhere. So I will not say that all autonomous agent applications, but a lot of cases just automatic summary of data and cleaning data and have a good representation of data as a kind of decision support system. And in 5 years, I think there will be application everywhere.
Thanks, Jianwei. Now we want to open up to the audience. Go ahead.
What will happen to humans? You see here, those artificial intelligence makes the young people really dumb. A friend of mine, the doctor died because he's looking at my cell phone and found over a truck. That's first thing. Second thing, what happened to jobs? All these low-scale jobs, you're taking over robotics. So what do you think?
So that is a wonderful question. So I don't know if I thought I was one of my few classmates in college that would cite social implications of information processing as my favorite mandatory undergraduate course. I don't know if this is a common mandatory undergraduate course, but it absolutely should be. Yes, I mean, I have a keen awareness of the fact that I'm trying to create Skynet, right? It's not entirely out of the realm of possibility that we could create a tool that's so powerful it does something awful. I don't think it's very likely that extreme, but we absolutely are going to put people out of work. And we have a responsibility to do something about it, not just say, that's great, I'm going to buy a new Tesla, right? I mean, we actually have a vacation place way out in the country where nobody programs. Hardly anybody has a cell phone. There are people that don't even read, honestly, in America, right? This is shocking, surprising. They're wonderful people, but they're not technologically literate, in some cases not literate at all. They are absolutely going to be impacted by this stuff. We are not going to have truck drivers, we are not going to have taxi drivers, we are not going to have people working at tellers. I mean, it's amazing there are any people working at tellers left. We're not going to have clerks in retail. I mean, we're already doing a project to eliminate retail people with a mobile robot. Pepper could do this. I mean, it's a great application. It's going to make tons of money, but it is going to have an absolutely serious social impact. So, yeah, we should think about that, and we should do something about it, and not just buy our next Tesla, much as I would like another Tesla.
Great. More questions? Go ahead.
I'm actually a student working on robotics, and I have a very general question. So basically, there are two boys from campus where Silicon Valley, the New Center, that one stand on the side that all the things should go deep learning. Those professors, like Professor Peter Beer, Professor Sergey Levin, they do end-to-end training. So say if I have an image, then my input is my image, and my output may be somehow the steering wheel for autonomous driving, or maybe the motor command for robotic control. But on the other side, those people who do traditional controls, robotic controls, so they prefer a more inside way, such that I have a model. I studied kinematics, dynamics, I build a model, I somehow maybe linearize it, and then I do state estimation, I do decision making, and I input my optimal control to the robot. Both the way have their advantages, and both have their accuracy, and recent work shows that the deep learning maybe achieve higher accuracy of the robotic control. But the question is, what if my robot fails? So unlike NLP, as you said, or like image recognition, the consequence is just labeling. It's 1 or 0, basically. But if for robots interacting with the real world, what if I do a deep reinforcement learning in first 400 trials? I'm going to fail again, then until I break my robot. Every piece, my $200 encoders, my like $20,000 motors fails. Everything is broken in part. Until like 400, the first trial I stand up, I do bipedal walking. So I personally, I don't stand, I don't have a side. I don't stand each of side. So my general questions, what would you think about this? Do you have a preferable side? Or like, should I worry about not finding a job if I don't start doing artificial intelligence right now, right away, in the time I graduate? Thank you.
Dr. Jianwei, do you want to share your point of view?
I think slowly artificial intelligence is becoming kind of like water and air. So I think this will be the option course for all the different areas, and so use some general method for considering how to make fully use of this big data available everywhere. And now we have the problem of our dealing with our limited cognitive load with so much information, so much data, too much data sometimes. And so by using some tools of artificial intelligence helps you with dealing with this information overflow and have better organizations. And the first question is, I think, is about if the robot will do everything for us later, and there will be different ways to consider this problem, and I think Adam has also some comments.
Yeah, I mean, a part of the question, you asked a number of different questions really, but one thing that I didn't hear was, you really addressed the question of liability and explaining, right? If the robot fails, what do we do? So again, I'll make my pitch for symbolic reasoning, right? One of the other challenges of machine learning, and this is a challenge, of course, for those of us who are developers. I mean, I have machine learning developers, and all the time we're faced with this problem of, well, that experiment didn't work. Why didn't it work? We can't ask the machine. We can't ask the neural network. You know, we might even be able to look at the hidden nodes, but figuring out what actually failed in a deep neural network is extraordinarily challenging. Even for us as scientists, much less for end users and consumers. So, you know, there's also been a lot of psychological studies about people and how we don't necessarily always report how we came to a conclusion. There are things that we do that are instinctual, pattern matching, reactive, but we can still come up with an explanation after the fact that's plausible. It would be great if our machines could do the same thing. And to do that, I think, again, we'll need deductive sorts of systems that can do reasoning, that understand things about the world, where each of the nuggets or intermediate steps of the conclusion are individually explainable and expressible. If we had that, if we had machines that could, after the fact, say, you know, why did you do what you did? What's an explanation that's consistent with the instinctive, perceptual, pattern matching process that caused you to act? We'd have a machine that would be a lot more human.
Right. So
yes, and now as academic researchers, we come to the time to discuss about the limit of deep learning, for example. And as you mentioned, deep learning can do a lot and achieve also good progress. But as you also mentioned, it's a black box, and mostly you don't know why this kind of learning happened, why we come to this result. This kind of black box effect is actually one of the disadvantage or limit of this deep learning process. And as also here mentioned, we as a human, we have much more cognitive models than just deep learning. And we have reasoning, we have logic, and we have also this kind of concept grounding process. Perhaps the next stage is to how to use this deep learning as fundamental elements to learn a complex cognitive process, perhaps only to ground a symbol or as a kind of network of deep learning networks. And that's probably the next stage of the research.
great. Thank you, Dr. Jianwei and Dr. Adam. And let's give our panelists a big hand.